by parts, or you can say product rule in integration. This is about, like, we'll have two functions multiplied, u and v, and we have to integrate the product of the two functions. Then we have to follow a formula, which is first function integration of the second function minus differentiate the first function, integrate the second function, and whatever comes after multiplication you integrate that result. Okay, it looks kind of complicated, but when you do through, like, 2 3 sums, then automatically things will be more clear. So I can simplify this as first integration of second minus differentiate the first, integrate the second, and integrate, and this will be your result. So the choice of first function and second function depends on this series, the letters islet. Though this is not a like formula as such, but it is used and is pretty much fitting into the system. I stands for inverse trigonometric functions. This is existing, it's not created by me, it is there. L is logarithmic functions, A is algebraic functions, trigonometric functions, T trigonometric functions, exponential function. Now exponential function means not only e to the power x, it's any constant raised to the power variable is e to the power is exponential function. So constant raised to the power variable will be taken as the last function, second function always. So let's take some examples now. So see, the first question is x sine x. X sine x. How we do it? X is algebraic, T is like sine x is trigonometric. X is algebraic and sine x is trigonometric, and in islet you see your a comes before t, so algebraic is your first function and trigonometric is your second function. So we take first function as it is and integration of second function, so minus cos x minus differentiate the first 1, integrate the second, that is sin x, so minus minus plus cos x, and this result is to be integrated. So what you get is minus x cos x, integration of cos x, that is sin x plus c. Done. Then same, this is also you can try directly, like x log x. So because L comes, like logarithmic function will be taken as first and algebraic will be taken as second. Okay, this reminds me of few questions like which comes alone, like maybe you get a question only log x, then this is actually log x is the first function, and into 1 constant will introduce on your own and will take that as second function. So see, first function as it is into integration of 1 is x minus integration of 1 upon x differentiated log x, and that's x. So cancels, you get x log x minus x plus c. So when a function comes alone, like there is another example which is like sine inverse x. Now see, there is nothing with it, only one function. You will be writing sine inverse x into 1, and then apply by parts, taking this as first and this as second. Okay, so what you'll get? You'll get sine inverse x as it is, following the formula, into integration of 1, which is x, minus differentiation of sine inverse x is 1 upon under root 1 minus x square and x dx. So this is what? This is linear upon root quadratic. So you can create the differentiation on top, x sine inverse x, create minus 2x. So I write a plus half inside and balance with minus 2 upon 1 minus x square under root. Fine. So what? So we have its derivative created on top. We'll take 1 minus x square is equals to t. So t will be equals to minus 2x dx, which I have already. So dt upon root t, etc. Let's solve this one. This will be a nice sum. X sine inverse x. So first function is like, what do you take first and second function as? Obviously, I let. So inverse, as I told you, will be the first function and x will be the second function. So sine inverse x as it is, first function as it is, integration of x is x square by 2 minus integration of differentiation of sine inverse x is 1 upon 1 minus x square under root into x square by 2 dx. So x square by 2 sine inverse x minus half x square upon 1 minus x square under root. So the question arises, how we solve quadratic upon quadratic, So I taught you earlier in other special integral part maybe, that quadratic upon quadratic we create the denominator in the numerator. Okay. So I need a minus. Now see this meticulously. Yeah? 1 minus x square. I need a minus here to create this. So I put a minus and change the sign outside. And I need a 1. So I'll add and subtract 1. So what will happen when I split this? I'll get half 1 minus x square upon root 1 minus x square. So cancels to give you root on top. And minus half, because half opens with both. See, it's ready to get like integrated now. X square by 2 sine inverse x plus half what? This is your special integral formulas, root of a square minus x square. X by 2 under root of a square minus x square plus a square by 2 sine inverse x by a. Hope you know this formula. If you don't know, please learn these formulas. They are very important. Then minus half. What is this? This is sine inverse x, because it's 1 upon under root of a square minus x square is sine inverse x upon a plus c. So this will be your answer. This one, sine inverse x whole square. In this, you can take sine inverse x whole square into 1 and solve. But I prefer sine inverse x equals to t. So x will be equals to sine t. So dx is cos t dt. So see, your question changes to t square cos t dt, isn't it? So now you can apply by parts. So t square as it is, integration of cos is sine t minus integration of 2t differentiated t square. T square differentiated is 2t into sine t dt. So t square sine t minus 2 and apply by parts again. So that's t as it is into minus cos t minus 1 into minus cos t integrated now. Huh? So you get t square sin t minus minus plus 2t cos t and minus 2 integration of cos t sin t plus c. So we can't leave the answer in terms of t, you know, you have to get x back in the picture, and we can't like write this kind of thing that we write cos sine inverse x. Like t, if I put sine inverse x here, I have to convert it in terms of simplified form. So t square, you know, is sine square t, sine square x. T is sine inverse x. So t square is sine inverse x whole square sin t, that's x, plus 2x plus 2t, 2t. So 2 sine inverse x cos t. Cos t is sin t is x, so cos t is under root of 1 minus x square, and minus 2 sin t, that is minus 2x plus c. So you have to convert everything in terms of x. So now I'm going to teach you one very important format. E to the power x, if question is in the form of integration of e to the power x fx plus its differentiation f dash x dx. Let's see what it results in. So e to the power x into fx is one integral plus e to the power x into f dash x is another integral. So always take e to the power x as second function, this is first function, you know. So first function as it is, integration of e to the power x is e to the power x minus integration of differentiation of first function f dash x into integration of second function e to the power x dx plus, and this I carry forward, so it's e to the power x f dash x dx. Now you see these two cancels. Answer is e to the power x into fx plus c, which will be always a truth as long as we have e to the power x outside and fx plus f dash x. So what happens here, whenever we have a function plus its derivative and e to the power x outside, we can directly use this as a formula, that is e to the power x into fx plus c. Like for example, if I have, say I have e to the power x square plus 2x. Answer is e to the power x into x square plus c directly. You have to just mention the formula that since e to the power x fx plus f dash x is equal to e to the power x into fx plus c. Okay, so this will be the reason and that's it. Fine. So let's see 16th e to the power x sin x plus cos x. Sin x when differentiated is cos x, so answer is e to the power x into sin x plus c. 17th is very important sum. It's x e to the power x upon 1 plus x whole square to be integrated. So because of e to the power x, we always think of this formula first, if it is fitting into the system or not. Let's write this as x upon x plus 1 or 1 plus x whole square. Now do plus 1 minus 1 in the numerator in the bracket. So you get e to the power x. Now split. You get 1 upon x plus 1 minus 1 upon x plus 1 square. So you see fx plus f dash x. E to the power x 1 upon x plus 1, because 1 upon x plus 1, if you differentiate, you get its derivative. So e to the power x 1 upon x plus 1 is acting like fx, and this is acting like its derivative f dash x, and hence the answer is this. So let's talk about 18th now. In 18th sum, e to the power x 1 plus sin x upon 1 plus cos x. So clearly we have e to the power x, break 1 plus sin x. Sin x you can write 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. Split it now, make it e to the power x 2 sin x by 2 cos x by 2 upon 2 cos square x by 2, which is giving me tan x by 2 plus half sec square x by 2. I have written this outcome first and then I wrote 1 upon this, because 1 upon cos square is sec square. Why I have written it like this? So that we can see directly that fx plus f dash x format is coming. So it's e to the power x into tan x by 2 plus c is the answer, following the same format again. So this all follows, this will break as x minus 1 minus 2 and split, you'll get fx plus f dash x. Here it is already fx plus f dash x. Then this sin inverse 2x upon 1 plus x square is directly a formula 2 tan inverse x. You know from inverse trigo, the formula for 2 tan inverse x in terms of sin inverse is sin inverse 2x upon 1 plus x square. Now tan inverse x you can do into 1 and do by parts. This one, 21, let me explain that. It's e to the power 2x sin x dx. So some books will say that this won't follow Euler, and we take this as first and this as second, but I tried taking this as first and this as second and it's working fine. So follow Euler only, no issues. So it's first function integration of e to the power 2x minus cos x into e to the power 2x upon 2. E to the power 2x sin x upon 2. Now in this again apply by parts. So that's first, second again. So first function as it is, e to the power 2x upon 2 integration of e to the power 2x minus integration of differentiation of first, so that is minus sin x, so sign changes outside, and e to the power 2x upon 2. So you get e to the power 2x sin x upon 2 minus e to the power 2x upon 4 cos x and minus 1 by 4. Now this is what I started with, isn't it? See, I is e to the power 2x sin x, e to the power 2x sin x. We replace this as I only. That's why this question is important. So this I will go to that side and will become I plus 1 by 4 times I, and here e to the power 2x upon, let's take say 4 common, so that we get 2 sin x minus cos x. Now you take LCM, you get 5i by 4. So 4 by 5 goes to the other side and multiplies to this thing, and you get your answer. So I occurring again is important, and there are many sums existing, like one of the sum is sec cube x. Give it a try and ask me in the class. Sec cube x, break as sec x into sec square x, try with by parts, and you'll see I is again occurring to the other side, which we shift to LHS. Fine. Now in this one, take x cube equals to t and solve. Okay, it's not directly by parts. It's pretty easy. Huh? Take x cube as t, you'll see 1 by 3 e to the power t dt will occur. So 1 by 3 e to the power t, that is the one of the answers. Find one which one is fitting into it. Open this up and apply fx plus f dash x. Alright.